A raw score by itself doesn't carry much information about its location within a distribution. Let's say, for example, that this is your mark, the 63. You got a 63% on your final exam. Now, on its own, doesn't look like a great mark, but let's say that the class average was a 43%. Now, if that's the case, then your 63% is a significantly better mark than the class average. So this would be an awesome mark. On the other hand, if the class average was very high, maybe 92%, then this is a pretty poor mark by comparison. So what we need, if we're going to be looking at individual values and not always looking at the entire distribution, we need a method to standardize scores to allow for effective comparisons. We need some type of a measure that will tell us for an individual score where this sits within the distribution. And that's what a z-score does. So a z-score, which is a type of standard score, and by that I mean it accomplishes that job of telling us where we sit within the distribution. So a z-score, it does this. It conveys the exact location of your raw score within the distribution. It's not going to be the only standard score that, actually I should have written this type of standard score. It's not going to be the only standard score that you encounter in this course, but it's the first one that you're going to be working with. And so it conveys the exact location of a raw score within the distribution. Later on, what it'll allow us to do is it'll allow us to compare entire distributions. But for now, this is its job. A z-score conveys the exact location of a raw score within the distribution. Now, how it does that and how you can calculate a z-score using a formula, this is going to be the subject of some of my upcoming videos. But this is just the basic reason for it. So it gives us a chance to determine how an individual score sits within the larger distribution that it's a part of. And it can help you decide whether or not you have a great exam mark or a poor exam mark just with a single value.